Hi, this is Mr. Leader. I'm going to teach you section 9.5 about the distance formula and then about the equation of a circle, which is related to the distance formula. Okay, so this is 9-5. Oh, that's a pretty color. Maybe we'll switch to blue. Anyway, so if I start with any 2 points in a coordinate plane. That is this one, trying to draw a coordinate plane here as best as I can. That's not too great. I can move that down. There we go. So if I were going to find the distance between 2 points, say this point is -3, 2, -3, 2, whoops, -3, -2, right? And this point over here is 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Right? And I want to find the distance between those 2 points. I could draw in a right triangle, and then I could use the Pythagorean theorem. That's essentially what the distance formula is. It's just, you're just making right triangles. That's not the best right triangle in the world, but it will have to work. So what you're doing so you basically you want to find this distance here between this point 5, 4 and this point -3, -2. So the distance from here to here you could find by subtracting the x coordinates, or you could count, but we're going to do it more mathematically by going 5 minus -3, right? That's the distance between those x coordinates, which is going to be 8. And then I could subtract the y coordinates, which is going to be 4 minus -2, which is going to give you 6. And then I could just do the Pythagorean theorem, which is 8 squared plus 6 squared, which, oh, look at this. This comes out nice and neat. Which comes out to be 64 plus 36, which is equal to c squared. And then so c squared is equal to 100. So c is equal to the square root of 100, which is 10. That's nice and neat. So what I could have done is I could have called this point here x1, and this point x1 comma y1. And I could have called this point x2 comma y2, and I could have subtracted to get d is equal to the square root of x2 minus x1 would give me the distance between the x coordinates, x2 minus x1, and then I'm going to square that, right? And then I am going to go y2 minus y1, which is the distance between the y coordinate, square that, and then that would be equal to c squared. In this case, we'll call it d squared because it's the distance. And then I square root that, and this is the distance formula, okay? It doesn't matter which one you call x1 and y1 as long as you're consistent, because you're going to be squaring them anyway. And so the negative signs are going to go away. So it doesn't matter if I call this x1 and this x2, or this x1 and that x2. So it really makes no difference. But you got to keep the x's straight and the y's straight. All right. So let's just try one. Just using the point. So what's nice about the distance formula, all you have to do is plug it into the formula, and you don't have to worry about drawing a picture or the Pythagorean theorem and all that. So say I want to find the distance between the points -3, 1 and 4, -2. 4, -2. So all I have to do is plug and chug. D is equal to the square root of, let's call this x1 and this y1. Let's call this x2 and this y2. So I'm just going to subtract just to in this direction, just to show you it doesn't matter which you make positive and negative. Negative 3 minus, whoops, that should be a 4, sorry. Negative 3 minus 4 squared is x2 minus x1 plus y2 minus y1, which will be 1 minus minus 2, which makes plus 2 squared. And then I just simplify it. Negative 3 minus 4 is 7. You want to square that. Plus 1 minus minus 2 makes 3. Square that. And if this were negative, you have to put it in parentheses, right? Because this is always going to be a positive number. And so you get the square root of 49 plus 9, which is the square root of 58, which is an exact distance, okay? I don't think we could simplify that much more. If we rounded off to the nearest tenth with your calculator, you get that that's about 7.6 units, okay? Okay, that's easy. All right, now from the distance formula comes the equation of a circle, because if I take some circle and I put it in the coordinate plane, and let's start with a circle, say, of radius 2, or with the center at 2, 5. 1, 2, 3, 4, 5. Okay? Uh-oh, it's doing that weird thing. Let's go back. 2, 5. Don't do that, please. Come on. 2, 5. So this point right here is 2, 5. And I want the radius of my circle to be 4. Okay, so I'm going to grab my circle tool. Here we go. And I'm going to drag out until it's 4 units away. So here's a circle. Whoops, almost, with a radius of 4. Let's see if I could stretch that a little more. Won't let me. Maybe if I go like this. There, that's good. Okay, so anyway, now I have a circle with a radius of about 4. I want the radius to be 4. Here it is. So this is 4 right here. So if I pick any arbitrary point on this circle, brother. Okay, any arbitrary point on this circle with the center at 2, 5 and a radius 4, and I call this, let's try again, okay, I call this the point x, y, okay, then I can use the distance formula to find an equation of any point on that circle. In this case, the distance from here to here we know is 4. So I could say that x minus 2 squared, x1 minus x1 minus x2, or x2 minus x1 squared, okay, plus y1 minus y2, which in this case, or y2 minus y1, which in this case we'll call 5 squared, is going to be equal to the radius squared, which is going to be 16. And that's a relationship that's true by the Pythagorean theorem. And this works for any point on this circle, and this is the equation of the circle. So for instance, if I wanted to find like what is the what is the x coordinate when the y coordinate is 5, I could plug into this equation, okay, and I can say, oh, when the y coordinate is 5, I can go x minus 2 squared plus 5 minus 5 makes 0, right, equals, so plus 0 squared equals 16, which gives me x minus 2 squared equals 16. I can take the square root of both sides and I get x minus 2. When I square root both sides, I have a plus half and a minus half is equal to the square root of 16. That gives me x equals, I'm going to add 2 to both sides, 2 plus or minus the square root of 16, which is 4. Okay? And so what does that mean? That means that x is either equal to 2 plus 4, which is 6, or x is equal to 2 minus 4, which is negative 2. What does that tell me? That tells me that when y is 5, x is 6 or 2. So if I go up here, this is the point to this is the center to 5, okay? So when y is 5, a point on the circle is 6, comma 5 over here. Here's that point, right? And this point over here is negative 2, comma 5. And you can see from the graph that those are indeed those 2 points. So the general form, I know that was kind of fast and I did a lot of algebra there, but hold on, I gotta go check something. I'll be right back. So, moving on. In general, if I want to have the equation of a circle, let's put some arrows on the end of my graphs. That's what you're supposed to have. Whoops, that's not my graph. That's my line tool. Okay, so here's another trying to make a straight graph. Not being too successful, but that's okay. Now I want to take arrows off the end of this. So now say I have any old circle. Here's some any old circle. Let's try any old circle right here. And instead of calling this having a specific radius, I'm going to call this h comma k. Okay? And h comma k, that point, and I'm going to call this r, the radius of my circle. And I'm going to, whoops, I don't want lines on the end of that. Try again. Okay, I mean I don't want arrows on the end. So let's try again. Let's make a red radius. Here's the radius, okay? And I'm going to call this r. And this point over here, any point on the circle, I'm going to call x comma, that was a comma, x comma y. Alright? So now these points are related by the Pythagorean theorem, by the relationship and the distance formula, x minus h squared, that's the distance between the x coordinates, plus y minus k is the distance between the y coordinates squared by the Pythagorean theorem is equal to r squared. And this is the general formula for the equation of a circle, where hk is the center. Hk is the coordinates of the center. Okay? Coordinates of center. And r is our radius. Okay? Of center. And r is the radius. So this is the general equation of a circle. Okay? So how do we apply that? So we're going to do a couple examples. Find, oh, this just writes great. Find the equation of a circle. Equation of a circle with center at negative 3, 5 and didn't mean to make a fish. and radius 7. All right. So all I'm going to do is plug those numbers into that formula. X minus I. X minus h squared plus y minus k squared equals r squared. I know my h and k. I know my radius, so I could write the equation of my circle. X minus minus 3, okay, makes plus 3 squared plus y minus 5 squared equals the radius squared, which is 49. And that is the equation of a circle with a center at negative 3, 5 and a radius of 7. And if I want to find, for instance, what is the y coordinate when x is negative 3, I could go through that process on the last page and find that. And I could sketch this circle. See if I can do that. Sketch, sketch, sketch. Negative 3, 5, 1, 2, 3. Let's pretend that this is a point, negative 3, 5. Let's pretend that this has a radius of 7, and then I could just kind of sketch my circle. There it is. Oh, somewhere around there. All right. And so you can work, let's see, find the radius. So going backwards, say I had a problem like this. Let's go different color. Find, how's that? Find the center and radius of a circle with equation x plus 1 squared, x plus 1 squared plus y squared equals 12. Well, in this case, since x minus h is x plus 1, that must mean that h is equal to negative 1. And since y minus k is just plain old y, that means that k must have been 0. Okay? K equals 0. So the center of my circle, center, is at negative 1, 0. And this over here, 12, is the radius squared. So r squared is equal to 12. So r is equal to the square root of 12, which, since we are very good at simplifying square roots now, this can be written as the square root of 4 times the square root of 3, which is 2 root 3, which is about 3.4 something, or somewhere around there. Okay, 3.42, I'm not exactly sure, but I'm guessing it's in the ballpark. Okay, one more problem and we'll be done. All right, so say I have a problem like this. The center of a circle, let's change colors yet again. The center of a circle is, how come it's colored in like that? I don't know. Is 7, that is at 7, negative 3. And 1 point, whoops, I went backwards, is at negative 2, 4. Negative 2, 4, and 1 point on the circle is 7, negative 3. Find the equation of the circle. What? That's a the. I'm not going to go back and fix it. Equation of the circle. Okay? So it might be helpful to draw a sketch. I'm not going to draw it totally accurately. Okay? But you know that the center is at negative 2, 4. Let's pretend that's negative 2, 4. Okay? And then there's a point on here at 7, negative 3. And let's say this is 7, negative 3. Okay, so your circle is going, I don't know if it's going to fit on this sketch, but my circle, no, I don't want a shaded in circle. I just want a plain old circle. No, I don't want that. I want, let's see, what does this do? No, 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 no shade. Hey. Hello, hello. Let's just do this thing, whatever that does. Okay, so here's my circle, going like that. I want to find the equation of the circle. Well, I could find the radius of the circle by using the distance formula, right? So I know that r, or r squared, in this case, is going to be equal to 7 minus 2 squared, x1 minus x2. 7 minus minus 2, which makes 7 plus 2 squared, right? Plus the distance between the y squared, negative 3 minus 4 squared. That's r squared. So r squared is going to be equal to 81 plus 49, right? R squared is equal to 81 plus 49. What's that? 100 and something. 81 plus 49, 130? 130. So that's r squared. I don't actually need to find out what r is. I need r squared in the equation of my circle. And I know the center, so now I could write the equation of the circle. X minus h, so it's x minus minus 2, which is x plus 2 squared, right? Plus y minus 4 squared is equal to r squared, which I now know is 130. So that is the equation of this circle. And now I could find other points on the circle, or I could plug in and say I want to know when x is negative 6, what's y? And you can find you'll have two different y's because there's two different points on the circle where x is negative 6. So when you square root it, you're going to get two different answers. I'm not going to do that here. Okay, so that's it. You can begin your homework. Sorry if that's too long and there aren't any good jokes today. But we'll see you on the next time. And your homework is listed right by this video on Schoology. Okay, bye.